Let's analyze this series to determine its interval of convergence. First, we should note that it's a series in powers of x, or better said, powers of x minus 0, so the center of this series is 0. To find the interval of convergence, let's try the root test. The root test involves looking at the nth root of the absolute value of the nth term of the series and its behavior as n approaches infinity. So here our nth term is clearly -1 to the n x to the 2n divided by 4 to the n. Simplifying inside the limit, we find that this becomes the nth root of n, absolute value of x squared, so the absolute value there is really irrelevant, divided by 4. We've learned that the nth root of n approaches 1 as n goes to infinity, so this limit is x squared over 4. Therefore, what we know from the root test is that our series, which I'm going to label as star, our series star is absolutely convergent when x squared over 4 is less than 1 and star is divergent when x squared over 4 is bigger than 1. So this can be simplified to x squared less than 4 or absolute value of x less than 2. So this tells us a whole lot about what our interval of convergence is going to look like. What we don't yet know is what happens at the endpoints of that interval. So let's check the endpoints. The endpoints are 2 and -2. So at x equal to 2, star becomes n going from 0 to infinity, -1 to the n 2 to the 2n over 4 to the n. But 2 to the n is this 2 to the 2n is the same as 4 to the n. So those two terms cancel, and we end up with this series, which is clearly divergent by the nth term. In this particular case, the series we started with, the power series we started with, becomes the very same thing at -2 that it did at 2. So it's also divergent. So our interval of convergence is the open interval from -2